Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. Today, we are going to learn about wireless media from Unit 5 Networking Technology. Wireless media. We know wireless media plays a very important role in communication because they can easily travel through solid objects, they can easily reach rural and hilly areas, and the bandwidth is more as well as the data transmission speed is very high in the wireless media. Now, the wireless media is also used for communication between computers. Now, which wireless media we are going to use and how they are used and what are their significance, let us understand. Wireless media. From the electromagnetic spectrum, few waves were selected for communication, and one of the wave is the radio wave. Radio wave, which is also called as a very high frequency wave, it is used for variety of communication. They can cover large distance. They can travel in all directions. Radio waves are very easy to generate. They are available from less frequency to the highest frequency. That is the main reason radio waves are used in a variety of communication. Radio waves are easy to generate. They can travel long distance and can penetrate buildings easily. Hence, radio waves are widely used both indoors and outdoors. Radio waves are omnidirectional. That is, the waves travel in all directions in free space so that there is no need to place the receiver and the transmitter along a direct line site. So, whenever there is a transmitter or whenever there is a receiver, both need not be in the straight line. We can place it anywhere because radio waves can travel in all directions, due to which they can be easily receive the data in any direction. So we need not have to place the transmitter and the receiver both in a straight line. Radio wave communication has a variety of frequency ranges that are utilized for various communication applications. As I said, they are available from low value to the higher value, due to which they can be used for a variety of communication applications. As radio wave cover large distance, interfere between user is a problem. So government license is required to transmit radio waves. So whenever the communication channel, any communication channel, if we take a radio or else if we take a TV, if they are using radio waves for communication, they have to take proper government license so that they can transmit radio waves because they interfere with each other. Radio wave communication having a major drawback. The first drawback, it is disturbed by rains. So when it is disturbed by rains, when the signal travels, sometimes the signal bounce back, due to which it offers a lower bandwidth for data communication. So this is the demerit of your radio waves. Next, let us discuss about microwaves. Microwaves. Microwaves are widely used in many communication. Microwaves travel in a straight line. That is, they follow the directionality principle, due to which the transmitter and the receiver both should be in a straight line. Microwave travel in straight lines and therefore narrowly focused and concentrating all energy into the beam. For microwaves, transmitting and the receiving antenna should be accurately aligned. This directionality allows multiple transmitters linear in a row to communicate with multiple receivers linear in a row without an interference. For example, we know our earth curvature. If I want to transmit a data via microwaves from one end of the earth to the other end. So when I am using microwaves, I will place multiple towers with transmitting and the receiving antenna so that they travel in a straight line and finally they reach the receiver end. Multiple receivers and multiple transmitters are arranged in a linear in a row for this transmission without any interference. Since microwaves travel in straight lines, for longer distance, periodic repeaters are used. That is, periodic towers we require. Unlike radio waves, at low frequency, microwaves cannot penetrate buildings. High frequency microwaves can easily penetrate through the buildings, but the low frequency microwaves cannot be penetrate through the building. That is why this is not used for longer distance communication. And here the demerit of my microwave is when I am constructing continuous towers for transmitting and the receiving antenna, the cost of designing the network will also increase. That also becomes a demerit. Next is our infrared rays. Infrared rays are widely used for short distance communication. Where we can see infrared rays simply in our remote, that is in your TV or the VCR remote, we can easily see the infrared rays. Infrared rays, since it travels in a short range, it will not penetrate into building, it will not penetrate even in the neighborhood. That is why whenever we are using infrared ray for communication, we don't require any government license. They are relatively directional, cheap and easy to generate. Major drawback of this wave is that they cannot pass through solid objects. As infrared waves cannot pass through solid object, it means that an IR system operating in one room will not interfere with the other IR system operating in the adjacent room. For this reason, no government license is necessary to operate infrared system. Simply infrared system is 100 feet, students. We can't use it more than that. Packet radio. Packet radio is a digital radio communication mode used to send packets of data. Packet radio uses packet switching to transmit datagrams. This is very similar to how packets of data are transmitted between different computers on the internet. Packet radio can be used to transmit data long distance. So here you can see the diagram of the packet radio, where it is a combined packet having both transmitter and the receiver with different frequency. A radio packet is attached to each terminal and the computer. So you can see here the radio packet is connected, one to the terminal and the other to the computer. So via the terminal, the transmission will be taking place. The information entered on the terminal is transmitted using a packet radio and received by the computer. So whatever information is being transmitted on the terminal will be transmitted via the packet radio using radio waves, and then it goes to the receiver end. Information is processed and results are transmitted back to the terminal by the computer. So once the terminal sends the data to process, what will be the computer doing? It will process the data and again it will send to the packet radio via radio waves, then it goes back to the terminal. So these are the four basic wireless media. The more important is your radio waves, microwaves and the IR waves. Now, as I said, the wireless media is also used in computer communication. Let us discuss about the LAN-based wireless media. Now let us discuss about the LAN-based wireless media. As I said, the wireless media is not only used for communication, it is also used to achieve communication link between computers. Firstly, the infrared. Already we have discussed about infrared. So infrared transmission is limited within 100 feet. Up to 10 megabits per second bandwidth can be supported. As I said, it can't be used for large distance communication. Remote control of TV uses IR transmission. So IR, already we have discussed about IR in detail. Now let us discuss about the laser. Now in LAN-based wireless media, we can also use laser for communication. Why was the reason to select laser? Because of its speed and better bandwidth. In laser transmission, laser rays are used. Receiver and transmitter are in straight of sight. That is, here both receiver and the transistor should be in the straight line for transmitting the data. This can be used in LAN and WAN transmission. So whenever we are working with laser, students, if I am using for short distance communication, as per that laser will be selected. Then if I am using for long distance, then a different laser will be selected. So since it has been said that we can use in LAN and WAN transmission, the transmission will be taking place due to two different lasers for LAN and WAN. Next, let us discuss about narrowband radio. Narrowband radio is nothing, it will be having a single frequency. So the transmitter and the receiver need not to be in the straight line. They can be placed anywhere. In narrowband radio transmission, a single frequency is used for transmission. The receiver and the transmitter need not to put along a direct line of sight. So they need not to be in a straight line. Only in IR, microwaves, and your laser. In these three, we require the receiving and the transmitting station both should be in the direct line of sight. The range of narrowband is greater than infrared. Next is the microwaves. Already again here we have discussed about microwaves in our wireless media. In microwave, the communication link can be achieved in two forms. One will be terrestrial link and one will be satellite link. In terrestrial link, the earth station and the remote station, that is the receiver and the transmitting station, both will be in the earth. And periodic repeaters are used for communication. In terrestrial microwave communication, the transmitter and the receiver are earth-based. Telephone towers uses this type of communication, but we use periodic repeaters in order to communicate from one end to the other end. The next link is the satellite link. In satellite link, there will be a geostationary satellite 22,300 miles above the earth. So, whatever data you are going to send, first from the transmitting station, it reaches the satellite and then it comes back to the receiving station. In satellite microwave system, satellite are 22,300 miles above the earth. Each earth station uses satellite dishes in order to communicate with the satellite. So in order to achieve communication, we will be using proper dish. Let me show you few diagrams of our wireless communication. Radio waves. You can see there is a single transmitting antenna. The receiving antennas are aligned in different direction because our radio waves are omnidirectional. Next, this is used in your microwaves, laser and IR waves. You can see here one is the transmitting tower and the other is the receiving tower. Both are in a direct line of sight so that the signals can travel smoothly. This is how the terrestrial link is achieved. So you can see here the one end is the transmitting station, the other end is the receiving station. So you can see here periodic repeaters are used. Towers are constructed and each and every tower is having a transmitter and the receiver to transfer the data from one end to another end, and they are placed in a direct line of sight. And this is how satellite link is achieved. So you can see here there is a satellite above the earth. There is a receiving station and the transmitting station. So how the data transmission is going to take place? First, from the receiving station, transmitting station, the signal will be sent to the satellite with the help of the uplink frequency. The uplink frequency will be always 6 gigahertz. And once it reaches the satellite, again it amplifies it and again send it to the receiving end, and that frequency will be the downlink frequency, which will be always 4 gigahertz. Always keep in mind the uplink frequency will be always more than the downlink frequency. So by this we complete the concept of wireless media. We have left out with the advantages and the disadvantages. Advantages: high data rate by using larger bandwidth, which can give transmission speed around 24 kilobits per second. By this media, communication can reach rural and hilly areas. Bandwidth for digital data range from 1 to 10 megabits per second. This we have already discussed earlier. Now, what are the disadvantages here? The main disadvantage is the cost and the installation. So, let us see. The very high frequency waves are corrupted by atmosphere noise and error may introduced in data and affected by EMI. That is radio waves. Lack of security because radio waves may be received by anyone. Installation cost is very high and installation is complex. Attenuation is very high. It can be minimized by using repeaters. As we said that for microwaves we use periodic repeaters in order to avoid attenuation. So what will happen? This all comes under the disadvantages of wireless media. Next, let us understand the concept of multiplexing. What is multiplexing? In telecommunication and computer networks, Multiplexing is a method by which multiple, that is analog or digital signals, are combined into one signal over a shared medium. That is, in a single cable, two or many analog or digital signals will be carried out so that the bandwidth is shared. This concept is linked with our characteristics of transmission media, that is bandwidth and band usage. And in band usage, we have learned broadband where many channels share the medium. So how they are going to share the medium and how they are transmitting the data smoothly, we are going to learn via the technique called as multiplexing. This is the technique of utilizing an available channel effectively. There are three methods of multiplexing and it belongs to a broadband communication. There are three methods and it belongs to the broadband communication. We have space division multiplexing, that is SDM, frequency division multiplexing, that is FDM, time division multiplexing, that is TDM. Let us learn about each and every multiplexing. Firstly, space division multiplexing, that is SDM. This type of multiplexing is very easy to make the connection. One of the simplest form of multiplexing is the space division multiplexing. When multiple messages we want to transfer, what we will do, we will transfer it through the cable, and here each and every computer who is going to transmit the data at the other end will be having their own cable, but it will be available in time slots. So let us understand. This is the simplest method of physical multiplexing in which the physically individual communication lines are packed at the source. How many number of lines are there at the slots are there at the receiving station? The similar number of slots will be there at the transmitting station. That is, in both the end, transmitting and the receiving end, the number of computers that is going to be available will be same. If here I am going to have A, B, C and so on till n number of computers. This is my cable via which your signals is going to get transmitted. This is my transmitting end. The other end, that is the receiving end. Again I will be having A, B, C till n. So you can see how the transmission is going to take place. From A, there will be an individual cable which will be connected to A at the receiver end. From B, there will be an individual cable which will be connected to B at the receiving end. Similarly for C and so on till N. So here each and every computers that has been in the transmitter or else in the receiver end, all will be having individual cables and they will be connected to the other end. It allows individual line to each user. That is what I said. Each and every computer who is going to transmit the data will be transmitting in an individual way. Easy to install and use because it is one of the simplest connection. It is very easy to install. As I said, this was one of the most famous connection when multiplexing came into play. Let's see some more example. You can see here in the transmitting hem we have three computers, TX1, TX2 and TXN. This is my cable. You can see there is a individual cable has been there inside the medium for transmitting, and this is my receiver end. So how many number of computers are there in the transmitting end? The similar will be there in the receiving end. This is how the multiplexing is going to take place in SDM. FDM. FDM is similar like SDM, but in SDM we were using multiple cables inside the channel, but in FDM we will be using a single cable. So the single cable that is going inside the media, what it will be doing? It will be transmitting the data of each and every workstation, that is your computers, at particular frequency and a particular allotted time. In a particular frequency with a particular allotted time. Now here, instead of many cables, there will be a single cable. And here, when the signal is being transmitted, there will be a proper guide for the signal so that there is no distortion of the other signals. For example, each and every signal will be surrounded by an upper sideband and the lower sideband, which will be preventing the overlapping of other frequency or the other signal with the original signals. Whenever the data is being transmitted till it reaches the receiving end, it becomes free. So from the transmitting end, we are going to do modulation process. Now, what is modulation? We are going to mix it the carrier signal, a high frequency carrier wave with the original signal, and then we will be sending through the cable in the slot. And then when it reaches the receiver end, there will be a demodulation where both the wave will be separated and the original signals are received by the receiver. So let's understand. In this, a number of signals are transmitted at the same time, and each source transfers its signals in the allotted frequency range. A common cable is used instead of multiple cables. There is a suitable frequency gap between the two adjacent signals to avoid overlapping. Since the signals are transmitted in allotted time, so this decreases the probability of collision. The frequency spectrum is divided into several logic channels in which every user feels that they possess a particular bandwidth. Each channel is transmitted by means of modulation, and at the receiving end it is demodulated. So let us see here. Here I am having computer A, B, C, so on till N. So here each and every computers, they are having their own channel, own signal. They are having their own of their own frequency. Now it is transmitted to the receiver end. So before transmission, we are going to modulate. So at the transmission station, we are going to have a modulator. The modulator will mix up the low frequency signal wave with the high frequency carrier wave, and then it will be passed inside the cable. Of You can see a single cable is used in their allotted slots, and at the receiving end we have the demodulator, which will be separating the high frequency carrier wave and the original signal, and then it goes to each and every computer. This is how the transmission is being done in a. You can see here, this is also an example where we have the modulator. There are three channel baseband analog channels. They are modulated with the help of a carrier wave, and then they are merged in the single cable of particular frequency. Then here we have the receiving end where the process is being done demodulator. The filter why we use so that it filters the unwanted signals, and lastly it reaches the receiver end. Time division multiplexing. One of the convenient way, one of the efficient method of multiplexing is the time division multiplexing. It comes under the category of digital multiplexing. It is also further divided as synchronous and asynchronous time division multiplexing. In time division multiplexing, there will be a switch present which will be connected to the computers in a regular time interval so that the data is transmitted in a sequence way. In a similar way, at the receiving end, the data will be also received in a sequence way. Here we have a multiplexer and a demultiplexer, so that the multiplexer combines in the transmitting end many computers who is transmitting the signal into a single one, and at the receiving end, the demodulator will be again converting the one of the signal into many, and then it will be giving it to the station, that is the receiving station. TDM is a very popular technique of utilizing the cable of a physical channel effectively. In TDM, each user of the channel is allowed to transmit for a small interval after periodic time so that the user can utilize full bandwidth in allotted time interval. The physical channel sends information sequentially and receive in a sequence. So here I am having four channels A, B, C, D, and it is transmitting the data in a sequence way. This is called as a frame. And then at the receiving end, we receive the data in a sequence way. For example, if A want to send data A, B, A, and B want to send B, B, C want to send only C, and D want to send D, D. Now how the data is going to be transmitted in a sequence way. The first will be A, B, C, D. Second will be A, B, D, because here C don't want to send the data. The third will be A, D, because B don't want to send the data now. And lastly we have A. So in this way the data will be transmitting in the form of a frame. Again I am repeating, in A, the data that is to be transmitted, I am going to take three data, that is A. In B, we are having only two parts, B and B. In C, only one, that is C. D, again we have two parts, D, D. So how the data is going to get transmitted? First A, B, C, D. This is the first frame. Second frame A, B, D. Third frame A, D. And lastly only A. This is how the data will be transmitted in a sequence. You can see here how the data is transmitted. A, B, C, D is one frame and the next A, B, C, D is the other frame. We have here a multiplexer at the transmitting end so that it combines the many signal into one, and the demultiplexer so that it converts the one signal into many. Apart from SDM, FDM and TDM, we also have WDM, that is the wavelength division multiplexing, where the colors of different wavelength will be separated using a multiplexer and demultiplexer, but this is not in detail in your syllabus. Today's class we have learned about wireless media and the concept of multiplexing and its types. Thank you.